Hello everyone, I Akrity Singh from CP15 M2A section with token number RNTC 1522062 is present here to give my presentation on an autonomous vehicle. So proceeding with the subtopics, first of all I will familiarize about an autonomous vehicle, then why this technology has been invented or practiced, advances in this technology, its parts, working, advantages, disadvantages, future scope, and at last I will conclude my whole topic. So, an autonomous vehicle is a vehicle that can guide itself without human conduction up to an extent limit, and hence it is known as a driverless car, robot car, self-driving car, or an autonomous vehicle. Next, why this technology has been practiced or developed. As you all know that road accident is a common cause, and no other invention in the history of civilian technology has caused as much harm as the automobile. So hence autonomous plays a significant role in our lives and afford many benefits to society. And due to this road accident, nearly 1.3 million people dies per year, and on an average 3,287 people dies per day, and in addition to this 20 to 50 million are injured or disabled, and all these causes is due to the human error. So as to overcome all these problems, an autonomous technology has been practiced and invented. Now moving forward to the advances in this technology. So the first one is self-driving. Self-driving means it can drive itself without any human conduction. The second one is autopilot, means it can assist the driver during driving. Then it has also the features of an anti-lock braking system, that is ABS. That means it can apply the brake automatically or warns or acts in case of danger. And then it has also the feature of an adaptive cruise control, that means car stays a safe distance behind cars ahead of it. Then it has also the feature of intelligent parking, that means it can automatically park itself in the parking lot. And it has also the feature of blind spot monitoring, that means it warns if the car is in blind spot. Now here I have listed some important parts of this vehicle. The first one is the LiDAR system, the second one is the GPS, the third one is the radar sensors, and then ultrasonic sensors, video cameras, and central computers. Coming across the working of this vehicle. So as you can see here, I have again listed some parts which I have discussed earlier. So all these parts consistently work together to make this vehicle automated. So the first one was the LiDAR system that was mounted above the car, and it can rotate 360 degree, and it bounces off laser lights through which an object can be detected, and LiDAR can detect road lines also, and it can also differentiate objects. The next one is the radar sensors that is also installed in this car, and radar sensors bounce radio waves of detected objects and cannot differentiate objects. Then the GPS unit means it helps or plays an important role in navigation, and this identifies the precise position of the vehicle. And then video cameras gather visual information from the road and traffic control and send it to the controller for processing. So basically I would like to say that all this combinedly work, and this car or vehicle basically depends on or rely on the sensors and actuators. So here I have put on short clip to make the working of this technology more clear.
Self-driving cars are now a reality. Take a look around. Cars are already driving themselves on the roads of California, Texas, Arizona, Washington, Pennsylvania, Michigan, and many other cities. Though currently they are restricted to specific test areas and driving conditions. But how exactly do they work? Just like humans, they also face issues of traffic congestion, rash driving, potholes, trees, and other obstacles on the road. But again, how do they change lanes? keep a safe distance from other vehicles passing by, and how do they identify roadblocks? Let's take a closer look at how they handle such situations smoothly. You might have noticed a rotating device installed on top of this autonomous vehicle. Sometimes these devices are mounted on the bonnet. This device is called LiDAR. It acts as the eye of the self-driving vehicle, providing a 360-degree view of its surroundings in order to enable safe driving. Continuously rotating LiDAR system sends thousands of laser pulses every second. These pulses collide with the various objects around the vehicle and reflect back the signals. These light reflections are then used to create a 3D point cloud. An onboard computer records each laser's reflection point and translates this rapidly updating point cloud into an animated 3D representation. The 3D representation is created by measuring the speed of light and the distance covered by it, which helps to determine the vehicle's position with respect to the objects surrounding it. The 3D representation also monitors the distance between the vehicles that pass by and any other vehicle in front. It also helps to command the brakes in order to slow down or stop the vehicle. When the road ahead is clear, it can also allow the vehicle to speed up. LiDAR is also being incorporated into another development called pre-scan. In pre-scan, laser scans the road surface several hundred times a second. This information is then fed to the car's onboard computer and processed in a fraction of a second, which adjusts the individual.
So this is how it works. Now here you can see I have put on a good example of an autonomous vehicle, a Google's Waymo project, which has been practiced in Texas, California and many other countries. Now there are many benefits potential to automated vehicle, including greater road safety, environmental gains, more productivity, greater independence, better land use, contactless delivery, international competitiveness. It has also certain demerits. First of all, it is unaffordable, and driverless car would rely on the collection of location and user informations, quite possibly triggering major privacy concerns, and maintenance would have to be overseen. And this is the reason why driverless cars should not rely totally in this. Hackers can affect the vehicle's software. Reading a road signs will be challenging for a robot. Now here are some future scope. The immediate benefit an autonomous future would provide is improved safety. A world with AVS functioning on the road suggests there would be a significant decrease in car. And also the autonomous vehicle market is expected to reach between 300 billion to 400 billion by 2035 as predicted by research and market. Now I would like to conclude my topic by saying that the increase of the proportions of intelligent vehicles will make the road load more balanced, and the self-driving cars can avoid the peak and reduce the degree of road congestion. And combined with other models, the optimal self-driving ratio is about 62%. These are some listed sources from where I have taken help. Thank you.